So we're going to take a look at a direct variation problem using our four representations: words, a table, a graph, and an equation. So with words, we think of the perimeter P of a square is directly proportional to the length S of a side. And think about the sides of a square cannot be negative. So let's just pick out some positive values like 1, let's do 2, 3, 4, and 5. So if our side length of our square was just equal to 1, and there are 4 sides, our perimeter would add up to be 4. If our side length was 2, and then there are 4 sides, that would add up to give us 8. And then we could think of the rest in a similar way. So if our side length was 3, and there are 4 sides, they would add up to be 12. If the side length was 4, our perimeter would be 16, and then 5 will give us a perimeter of 20. So let's graph those points, and I've changed the graph so that it's really like the first quadrant, because none of our values should be a negative with this problem. So if we graph 1, 4, considering this to be our origin now, so 1, 4, and then 2, 8, and 3, 12. It shows us that a direct variation problem is really a linear function. And then to write out our equation, we can find the constant of proportionality just like we would find a slope. So notice your change in y is increasing by 4. So we put like change in that y value on the top over the change in our x value, which was just 1. So our slope is like 4, or we multiplied by 4 for every time we added a unit to our side length, I would say. So we would say that the perimeter, let me grab a different color for this part. The perimeter would vary depending on 4 times the side length. So the constant of proportionality, our k value, in this case was just